Chapter 34, Lenses and Mirrors. In this chapter, I'm going to tackle several ideas. One, I want to talk about the ray model of light and what is it that we see, along with the importance of ray diagrams. Then I will look at lenses, mirrors, a two-lens system, and then a combination of lenses and mirrors. So now I'm going to start with number one, which is the ray model of light and how we see. Our everyday experiences tell us that light travels in straight lines. For example, think about a flashlight or a laser. This model is an oversimplification of reality, but useful nonetheless. So now what I want to do is highlight what do I mean by the ray model of light. And it turns out that there are four things that we got to talk about. Light rays travel in straight lines, and rays do not interact when they cross. That is, if I cross two lasers, nothing happens as these cross. 2. Light rays that interact with matter do so four different ways. They could either reflect, refract, get absorbed, or scatter. 3. When we see an object, one must shine light onto it so that light scatters from its surface. This light that reflects and scatters in all directions with an infinite number of rays. Let's draw an image of that. When incident light shines onto, let's say, this light blue paper, light will be reflected and scattered in all directions. The eye sees objects like this blue piece of paper by grabbing a finite number of bundles of light rays and then focusing them on the retina. So my eye then does the following thing. So these red beams here are from each of the scattering spots. The eye intercepts some of these light rays, and this is what's focused on the back of your eye, the retina. So what happens here now is that your visual system processes the information provided by the light. Now the visual system processes the information and an image is created in your brain. That is, light rays that come from an object that are reflected, refracted, absorbed, and scattered will either converge or diverge from a point called the image point. Our goal in this chapter is to see how this is done and to explore the different kinds of images that can be made with simple optical devices, with lenses and mirrors. Before we move on, I want to talk about one last thing that's interesting. How do we see an object? In order for our eye to see an object, rays from the object must enter the eye. This sounds obvious, but many times it isn't. One example is a green laser light. No light from a green laser enters your eyes since the laser travels in a straight line. In order for you to see the laser light, it has to scatter off of small particles. If laser light travels in a straight line, then since no light will go into my eye, the laser that we see is typically a green spot on the wall. In order to see it, we need to put particles into the air so that light can scatter off of those particles and into your eye. If I now spray the air with dust particles, light can scatter off of these dust particles, and that scattered light will then go into my eye, and we then see the laser. Now let's apply this idea to seeing stars from the moon during the day versus stars from the earth during the day. Although this is not a real image, it is accurate. On the moon, stars can be seen during the daylight. However, during the daylight on Earth, stars cannot be seen. Why is that? Light scattering from the atmosphere overwhelms starlight. On the other hand, since the moon has no atmosphere, there is no scattering of light, and therefore one can see stars on the daylight side of the moon.